Hello everyone, my name is David O'Brien, and in this video we're going to be looking at binary search trees and skip lists, which are basically sorting algorithms, and we'll get soon into why they're really efficient. But first we sort of have to construct some of these, so let's add some nodes to these. So we'll add 20 first, and then the second node we're going to add is 40. And so when we're inserting into the skip list, we actually need to flip coins. So we're saying if we land on heads or get like a 1, we add an extra node, and if we land on 0, then or tails, we stop adding extra nodes. So we basically flip until we get a 0. So we got 1 and then 0. So when we add the 40 to this, we're going to say 1, 0. So it'll insert one extra node above the bottom row, and then it'll stop. So let's actually look at this next one we insert, so 10. So with the binary search tree, the 10 is going to go to the 20. It's going to say, okay, is it greater than or equal to 20? The answer is no, so it's going to go to the left. And there's no other nodes here, so it'll just insert it. If it was greater, then it would go to the right, which is what the 40 did, and then it just recursively does that until it finds an empty spot to put the node on the tree. So let's flip our coins now for the skip list. We got 0 for the first one there. Didn't mean to flip the next coin. So what it's going to do is basically similar to the binary search tree. It's going to do a lot of comparisons to pick where to place the 10. So if we actually look at the steps here, it starts always on this one at negative infinity. It says, okay, the one to the right of here, 20, is 10 greater than, or is 10 greater than 20? It's not. So it's going to just go down. Look at it again. Is 20 greater than 10? Is 10 greater than 20? No, it keeps going down. Once it realizes it's at the bottom, it's like, okay, we know where we need to place the 10. So it breaks the edge between the negative infinity and the 20. Adds the 10 there with the proper edges. And then it looks at our coin flips. We got 0, of course. So it's not going to place any extra nodes, and that's all for that. So let's keep adding some nodes to these trees and skip lists. So let's add another 20 to here. So for this, if it's greater than or equal to, it'll go to the right. So it does that, and then it looks at the 40. It's like, okay, it's less than the 40, so it goes there. The interesting thing with, if we try to insert the 20 here, this visualizer, for some reason, if it finds the 20 is already there, it's not going to add it. I think other skip lists, it will actually make an effort to add duplicate values, but this one doesn't do that. Maybe the instructor just wanted, it to be easier to understand or whatever. But either way, that's why that doesn't happen. So let's insert a 5 here. That's really easy. It's less than all of these, so it just goes all the way to the left. Let's flip our coins for the skip list. So we're going to get 1, 1, 0, 1, 1, 0, add our 5, and yeah, so it's the lowest value in this again, so it'll go all the way to the bottom, and then see it's less than a 10 too, so it puts it right here. Let's now insert 80. So here, very easy, it's the largest value, so it'll make its way all the way to the right. If we flip our coins for this, we got 0. So we add 80 to this. Once again, it's just going to make its way all the way to the right here, and then insert the 80 right there. Next value we got to deal with is 20, and we're deleting it. So for this, for the binary search tree, it'll delete it, and then it'll see, okay, which node is closest to the 20? The 10 is, so it moves it up there, deletes the 10, and then looks at the 5, and it just recursively does the deletion. So it's only one edge from the 10, and it's to the 5, so it just shifts it up basically. So that's very easy. That's how deletions work. If there's nodes below it, it'll just recursively delete and delete until you get to a leaf, and if you delete that, then yeah, you don't really have to do much else. And then we're deleting 20 here. So again, it just does the comparisons, finds the 20s, and then it'll just delete those. So very easy. These sorting algorithms are very useful in computer science, that is for sure. So next we gotta insert the 100. Again, it's the largest value, so that's very easy. It'll just make its way to the right. Let's flip our coins here. We got 0. That's pretty unlucky. I've been getting a lot of heads today when I've been messing around with this, but yeah, we'll insert the 100. 100's the greatest one we have here, so it'll make its way to the right and do that. Next, we have to insert 20. So what it'll do here is it'll make its way, let's look at the steps here. It'll look at the 10. 20 is greater than or equal to 10, go to the right. Less than 40, so go to the left. Greater than or equal to 20, because it's equal to it, so it goes to the right. No nodes there, so it inserts itself there. Let's insert the 20 here with a head and then a tail. So with this, it makes its way to the 5, because 20 is greater than 5. And then from here, it's looking at positive infinity. Of course, it's not greater than positive infinity. So we're going to go down, look at the 40, not greater than 40. Okay, we got to go down again. It's actually greater than the 10, so we're going to move to here. Still not greater than the 40, so we try to go down again. We're at the end, so it's going to delete the edge, place the 20 right here, and then add an additional one because we landed our coin flip on heads once. So that's how to do that. So let's get 30 into the binary search tree, and then it'll find the spot right here actually, because it's greater than 20. I'm very bad at mental math. We got 0 again with the coin flip. That's pretty unlucky. So we'll insert that here. Let's find its way down here and just add 1 node. Next up, we got to delete the 5. So what we're going to do is go here. And so for the binary search tree, this is very easy. 5 is a leaf. So what it'll do, it'll go to the 10. It'll try to find it first. So it'll say, is 5 greater than or equal to 10? No. So let's check the left. There we found the 5 because it's equal to 5. But because it's a leaf and there's no nodes below it, we can just simply delete it. We don't have to recursively call the delete on the nodes below it or find the nearest value to 5. It's just very simple. Now let's remove the 5 from here. And so because 5 is our lowest value, this is actually going to be really easy. So let's look at the steps again. We start at negative infinity and we're like, okay, is 5 greater than or equal to negative infinity? Of course it is. Sorry, is it greater than negative infinity? Yes. So we go next. There, bingo, we found the 5. So we just follow down. Of course, it's not greater than positive infinity, not greater than 20, not greater than 10. And then at this point, we're like, okay, here's the 5. We found it. We're just going to delete all these and we're done. Okay, next, let's add 50 to here. And then that'll find its way, here. And then we'll flip our coins. 0 again. Oh my gosh. Okay, that's very unlucky. So 50, it'll find its way over here. And then for the last step, we need to search through these. So for 80, basically what the binary search tree is going to do, and there we go, we found it in just 3 steps. It's going to go to the 10 and be like, okay, 80, greater than or equal to 10? Yeah, so we'll go to the right. 40, greater than 80, greater than or equal to 40? Yes, we'll go to the right. Bingo, we found the 80. So in just 3 steps, we managed to find our value. So that's very efficient. Now we'll look at the skip list. And the skip list is going to go very fast. So I'll break down the steps here. So it takes a couple of steps there, but it did find it. So basically it starts here. It's like, okay, negative infinity to positive infinity. Actually, it shouldn't really have this. I think it's only because we deleted the earlier 20 that this is still here. But yeah, we know it's definitely not there. So we go to the next one. So 8, yeah, we're looking for 80. Is it greater than or equal to 20? Yep. So we move down there. Greater than or equal to 40? Yep. So we're going to move down there. Greater than or equal to positive infinity? Of course not. So we move down and then we're at the bottom, so we're going to look through all these. Eventually we'll find it. Then we're like, okay, bingo, and delete it. So as you can see, if we had just lined these up in a list, we actually managed to skip some steps. We skipped the 10, we skipped the 30. And if we had, more values for some of these, if I didn't land on tails every time, we could have, potentially at one of these stages cut all the way to 80. So yeah, these are very efficient algorithms. They're very good for sorting and finding numbers. And so yeah, that's how they work.